Welcome back to Spring Into Math. I'm Mr. Burns, your instructor today. Today's topic is more in depth about the term slope. So let's take a look. Let's take a look first at some examples of what slope can be. Think about the pitch or the steepness of the roof on your house or the roof in the building that you're at. All those have slopes. How about a ladder leaning up against a wall? That creates a slope, a certain amount of steepness depending on the height of the ladder and the height of the object the ladder is leaning against. Remember that slope is the steepness of a line or rise over run. Now here on this graph, now it may be a little hard to see, so you may have to pause it, but here on this graph we have a line graphed. We've also drawn a triangle and it's got 3 yellow dots on it. The dot on the y-axis is one place where this line crosses exactly in the corner, and the one on the x-axis is another place where this line crosses exactly in the corner on a graph. In order to find the slope, we need to count the rise over the run. So in this case, our rise is not going up, it's actually going down, and it's going down 2 units. And then we're moving 3 units to the right. And again, just so you know, usually it's called rise over run. However, we can't have negative numbers in this. So we're actually moving down 2 units and over 3 units. So the slope of this line is -2/3. Okay, now let's talk about the exact formula how we find slope when we're not looking at a graph and we're just given sets of coordinates to work with. So slope can be found by using any 2 points on a graph by using the following formula. Slope equals y2 minus y1 over x2 minus x1. Now we're going to run through a couple examples together, but this would be a great place for you to stop and copy down this formula into your notes as you're going to need it. Okay, we're going to use the following coordinates to find the slope of the line. Now notice we have no graph here, so we're not having a visual, we're just working with coordinates in order to find the slope of the line. And I've listed the formula here above it, or below. y2 minus y1 over x2 minus x1. Now the coordinates we're working with today are 3, 2, and 8, 6. So we're going to go ahead and insert those numbers into the formula. So you can see below here that I've written 6 minus 2. Those are the y values. The second y value is the 6. The first y value comes from the first set of coordinates, which in this case is 2. And then we put on the denominator part the x values. The second x value is 8. And the first x value is 3, so we have 8 minus 3. So let's go back here to the numerator of our new fraction. 6 minus 2 makes 4, and 8 minus 3 makes 5. So we know that the slope of the line with the coordinates 3, 2, and 8, 6 has a slope of 4/5. Okay, now we're going to ask that you try this one all on your own. So use the following coordinates to find the slope. And again, here I've listed the formula for slope. y2 minus y1 over x2 minus x1. Pay attention to the negative signs we've thrown in here. -6, -2 is the first coordinate, and 2, 9 is the second coordinate. Go ahead and pause the video and try to figure it out. All right, did you get it? Let's check. I've inserted the numbers here into the formula. I have on my y values 9 minus -2, my x values 2 minus -6. Now remember, we do something interesting here when we have a minus a negative. The minus sign and the negative sign actually turn into an addition sign. So 9 minus -2 makes +11, and 2 minus -6 actually turns into +8. So my slope is 11/8. Now that is called an improper fraction, and most people like you to reduce improper fractions into mixed numbers. So I've done that here for you as well. So 11/8 actually turns into 1 3/8. Here's how. 8 goes into 11 one whole time evenly. There's our big number, 1. And then I would subtract 11 minus 8 gives us 3, and that's our numerator. And of course, the denominator 8 just travels over and remains the same. I hope you had fun learning about how to solve slope and using coordinates and the formula. Catch you next time.